All right, good. So welcome to lesson unit 4.7, part 1. We're going to do a part 2 tomorrow. There's no quiz tomorrow, which we usually do, but not today. We're going to be talking about position and velocity. So if you guys are in physics, some of this stuff might sound familiar. Some of this might sound familiar. So let's begin. First of all, let's talk about what a position function is. A position function is a function that tells you where a moving object is located at some point in time. So I could give you this function. What you do is you plug in a number, which usually represents the time. The output would be where it's located on a number line. Okay. So f of t equals s. The t in this case represents time. The s, or you could just call it f of t, because f of t is s. They both represent the coordinate of the object's position at that time. So, for instance, f of 2 equals 5 means, and you guys should probably write this, this means that at t equals how many seconds? 2 seconds. And I'm just making up seconds. Maybe it's minutes, maybe it's hours. I don't know. I'm just making something up. That's why I say it could mean. At t equals 2 seconds, the object is at coordinate 5. Now, usually, when we're doing these, we're talking about an object moving on a horizontal or a vertical axis. So if I say 5 and we're on a horizontal axis, that means like we're 5 spaces to the right. If we're on a vertical axis, 5 would mean we're 5 spaces up. Okay. Does anybody need me to leave that up there, or are we good to roll? Put it on Pinterest. All right, let's talk about displacement. Displacement is a number that represents the distance and direction of an object's final position. Bad English. An object's final position from its starting point. Okay? So, displacement is the change in the object's position from time 1 to time 2. So, like maybe right now, t1, I'm here, and at t2, I'm over here. Okay. Yeah. Mind-blowing. So position at t2 minus position at t1, or you could write it like this, right? F of t tells you the coordinates. So f of t2 is the position at t2. F of t1 is the position at t1. And if you subtract those, that's another way to write the same thing. You get what I'll call delta s. You remember what delta means? Good job. So it means the change in s, or the change in position. All right? For example, if I gave you this, f of 1 equals 8 and f of 2 equals 20. First of all, what does this mean? So at time 1, we're at coordinate 8, and at time 2, we're at coordinate 20, right? So if we did f of t2 minus f of t1, my t2, what's my second time? No. 2. And what's my first time? 1. And what is my position at my second time? And what is my position at my first time? And what's 20 take away 8? 12. Now this object's displacement is 12. Now, but don't miss the significance of the fact that this is a positive 12. So if I were on a horizontal axis and my displacement was positive 12, that means that wherever I started at, my final position is 12 spaces to the, well, probably, yeah, this is your guys' right. My position would be 12 spaces to the right of where I started. That's what that means. So let's write that in English. The object is 12 spaces either to the right or above its starting point. The object is either 12 spaces to the right or 12 spaces above its starting point. No, because usually we only talk about it moving on a horizontal or a vertical axis. Let's continue. So, let's talk about axes of motion and interpreting S and delta S. So, remember, this is position, and this is displacement. So they're different things. So S is position, that's the coordinate at some point in time. Delta S is displacement, or the change in position. Yes, you've been texting this entire time. You really should be paying attention. You really should be paying attention. All right, so this first one here, we're going to talk about on a vertical axis. In this case, the coordinate is located above the origin. Located above the origin because it's positive S. So like if we're on a vertical axis and I told you the position is 3, that means it's 3 spaces above the origin, right? If it's negative, that means we are located below the origin. No, that's a good question. So Elizabeth was asking, is the starting point at the origin? No, it's not. So like on the example I gave you guys, remember f of 1 equals 8? So at t1, 1, we were at 8. So not the origin. So it doesn't have to start at the origin. All right. Delta S. Now if you have a positive delta S, that means that final position is to the right of its starting position. So the final position is to the right of its starting position. And you guys could probably guess what this means here. Uh-oh, I made a boo-boo. You guys see my boo-boo?
You said start. Because you put positive. Start instead of work.
I said right and left.
Oh. I wouldn't have known. I thought that was just part of the thing. Yeah.
All right.
I would have just believed you if you never caught that.
Final position is above starting point. I was thinking of a horizontal axis. Final position is below the starting point.
Is the starting point or origin always 0, or
No.
are we gonna?
No, good question, but no. All right, horizontal axis. If you have a positive S, that means it's located to the right of the origin. A negative S means it's located to the left of the origin. A positive delta S on a horizontal axis means that the final position is to the right of its start.
Right?
Yep, that's it. And for this one, the final position is to the left of its start. Okay. Okay, now we get to do an example finally. A particle is moving along a horizontal axis according to the position function, blah, where t is measured in seconds and f is measured in centimeters. We like units. Find the object's position at t equals 4 seconds. Any idea what to do there? Plug in 4. That's right. So we're just going to plug 4. Maybe it is 6. I think you're right, Justin.
No. I was looking at number 2.
Oh, no. It,
I was looking at number 2.
I see. What is my unit there?
Seconds.
Centimeters.
Centimeters. It's a distance, but it's a position. So are we on a horizontal axis or vertical? We're on horizontal. I should have known that too. So that means that this object at t equals 4 seconds is 6 spaces to the left of the origin. Does that make sense? Okay, so let's do this one. F of 2, that means we're plugging 2 into the function. And yes, that one is 6. And let's interpret that. Someone want to take a crack at it? Part of it. Go ahead, Luke.
At f equals 2, at t equals 2 seconds, the particle moves 6 centimeters to the right.
Let's say the particle is at 6 centimeters to the right.
Why didn't we want to say?
Because if you say it moves 6 centimeters, that means it went 6 centimeters to the right, but it might not have.
It might just like have
It's
been
at 6 centimeters. Matter of fact, let me ask you this. Where is the object's starting point at t equals 0? It's at 10. You plug in 0, you get 10. So the object's at 10. So after 2 seconds go by, the object is now at 6. So the object actually moved to the left. Right? It started at 10. 2 seconds later, it's at 6. So it moved to the left.
So does that mean
It's still positive 6 because we're not to the left of 0 yet. But it's so if you think of a number line, here's 10. After 2 seconds went by, my object's over here. That's what happened. It's still a positive 6 because 0 is over here. It's not in the negatives yet. But apparently at t equals 4 seconds, after 4 seconds go by, now it's at negative 6. So this object seems to be moving left.
because it's still to the right of the origin?
The position is 6 spaces to the right of the origin. How about that? Of the origin. That's clearer. So if that was confusing to you too, you might want to put 6 spaces to the right of the origin.
Wait, so when you said origin, you mean
Uh-huh. Yep.
okay.
Or if you guys just want to do this, you could do this instead of saying 6 spaces to the right of the origin. You can just write it as a point. 6 comma 0, like x comma y.
That's just like the answer.
I would say that's probably not the best thing to do though, because you're assuming there's a y-axis, and this problem doesn't talk about a y-axis. We're just talking about an x-axis and time. There's no talk of a y-axis. So I don't
6 comma
prefer
y?
this, but it is shorter.
You do 6 comma y.
Well, no, the y would, yeah, so that, yeah, it's confusing. I would say no. I kind of like it worded the way that it's worded there. All right, let's take a look at this. Find and interpret f of 4 minus f of 2. First of all, we had f of 4. What is f of 4?
-6.
What is f of 2? Okay. What's the answer? -12. All right, guys. What is that?
It's a number.
We want to interpret it though.
Yeah, it's the position of T at this object is
I'm hearing a lot of good stuff. So let me say what you guys. I've heard some voices. I'm going to put some of your thoughts together. You guys are good. So I heard somebody said final versus starting. Okay, that's kind of okay, not bad. And then Jesse, you were getting a little more specific. You were saying the object position at 4 seconds minus its position at 2 seconds. Now, what is it when we take two positions and subtract them? There's a word I gave you guys for that. Displacement. Displacement. So here's how I'm going to word it. Although you guys could have said this. You could have said the object position at the difference between the position at 4 seconds and its position at 2 seconds. That's 100%. That's right. But I'm going to use the language we've been working with today. So I would say the displacement from t equals 2 to t equals 4 is negative 12. Is the object located to the left or right of where it started at 2 seconds? It's to the left. At 2 seconds it was here, and then at 4 seconds it's here. So its final position is 12 spaces to the left of where it was at 2 seconds. This is at t equals 2, and this is at t equals 4. So its displacement is negative 12 because we went 12 spaces to the left after that point. So that's called a displacement. But the way you guys were saying it would count. And you could say, you just have to be more specific about the times. You couldn't just say final versus start. You have to be more specific with the times. But that's that. All right, so, yeah. This is a student practice, which we'll see how time works out and coming back to that. Okay. Another one. Average velocity. Average velocity is your displacement over time. In other words, so let's think of the last problem that we did. What was the displacement? It was negative 12. And the time was from t equals 2 to t equals 4. How far apart is that?
2.
So it seems like this object moved 12 spaces to the left in 2 seconds. That means its speed is what?
It's like
Centimeters per second.
So its average rate of change on that interval is negative 6 centimeters per second. Okay? It went 6 centimeters per second on average. Now really, maybe its speed was changing along the way. We don't know. We just know that the total distance and the total time, or I should say the total displacement and the total time, gives us that. So notice that the average rate of change, this is just the average rate of change formula that we've learned before. You guys know the average rate of change. Remember average versus instantaneous? Okay, this is just average rate of change. Because velocity is the rate of change of position. How fast an object is moving is its rate of change of its position. All right. So let's talk about axes of motion and interpreting average velocity. If you're on a vertical axis, what do you guys think a positive velocity means? Vertical. It's moving upwards. So velocity tells you how fast, but also what direction. So on a vertical axis, positive means your object is moving up. Moving up. Negative means moving, I keep making my O's into A's. Moving down. And on a horizontal axis, what do you think this means?
Moving right.
And this one? So velocity tells us what direction we're going. Speed versus velocity, let's talk about that. Speed is the absolute value of velocity. So, guys, velocity tells you how fast and what direction. But if you take the absolute value of it, you're ignoring the direction. You're just looking just at speed. Okay? So speed only indicates how fast an object is going, but it does not indicate the direction. So you got to pay attention carefully on your questions. Am I asking for speed or am I asking for velocity? All right, let's take a look at this one here. A billiard ball, that's a pool ball, is dropped from a height of 100 feet. The ball's height at time t is given by that position function there. So in other words, if I plug in a time, it will tell me how high up the ball is at that time. That's a position function. They want me to find the average velocity and speed on the interval from 1 to 2. And they want me to do the units. So we need to find its position at t equals 2. And we need to find its position at t equals 1 and find out what's the difference between those. That's my displacement over that time interval from t equals 1 to t equals 2. Seamus, you're in la-la. Come back to us. Make velocity. So h of 2 minus h of 1 over 2 minus 1. All right, let's calculate what h of 2 is. How would I find h of 2? That's right. So if I plugged in 2 to this formula up here, I'm going to get 64. Actually, 36, my bad. I didn't do all of that. All right, minus, what if I plugged in 1? Maybe one of you guys can beat me this time. Thank you.
I think you were right the first time. Isn't it 64 because it's 2 squared times 16?
Yeah, and then add 100 to it.
Oh,
That's what I did the first time. Now, just so you guys understand, 36, that means after 2 seconds have gone by, the ball is now at a height of 36. At 1 second it was 84. So it went from 84 feet to 36 feet in just 1 second. So that's a fast drop. So let's go ahead and subtract those. Help me out there. I don't know what that is. 48? Maybe somebody can double check me on that.
Negative 48.
Okay, now let's get our units on there, guys. This is negative 48 what? Feet per second. Good. The top is feet, the bottom is time. So this ball dropped, negative, it dropped 48 feet in 1 second.
Do you have like expected that?
I don't know. What's the average speed?
That's gotta be 48.
Yeah.
That's gotta be 48.
The average speed is equal to the average velocity, so that would be the absolute value of 48, which is just 40. In other words, the negative on that velocity tells me that the ball is moving. Which way?
Wait, sorry, say that again?
The negative on that 48 tells me the ball is moving which way? It's moving downwards. But if we just take the absolute value of it, that's just the speed.
What is like negative?
So 48.
There's no. You don't do that. Speed is strictly absolute. All right, guys. Let's talk about instantaneous velocity. Yeah, so, guys, whenever I take an object and I drop it, what is its speed when I first let go? 0. There is no speed. And then it goes faster and faster and faster. So the speed is changing over time, right? So this is not a constant speed we're talking about. This is a speed that's speeding up. It's accelerating. All right? So what we just found in the last problem, that was an average velocity. I looked at a starting time and an ending time, and I found the difference between them, and that's my average velocity, right? Here, we can find how fast it's going at one specific point in time, okay? How do you do that? Well, instantaneous rates of change are how you find that. So if you take the instantaneous value of velocity, that's the same thing saying take a derivative at that point, okay? So if the position of a moving object is given by this position function, then the instantaneous velocity at c is given by finding the derivative and plugging that number in, right? So Let's do one of these. A diver jumps off of a diving board. The diver's position is given by this position function. So this is a formula where if I plug a number in for t, it will tell me how high up the diver is at that point in time. Right? So t is in seconds, f is in feet. So let's do this first. What is f of 1?
32.
32? Let me catch up with you. But you're just plugging it into the function, right? And I agree, because that's just going to become negative 16 plus 16, which cancels out, and I'm left with 32. Now, guys, what are my units on that? Be careful now. It's f of 1. Yeah, that's feet. What does this mean? This means that at t equals 1 second, the diver is 32 feet in the air. That's what that means, okay? Now, the next one, though, is asking me to find and evaluate f prime of 1. That's a different thing, right? That's an instantaneous velocity. So first of all, let's find f. Oh, I didn't write it. Let's write our answer. At t equals 1, the diver height is. I'll wait a second because I didn't put the interpretation there.
So the interpretation is that.
Yeah, well, so here's the answer I got, and then I just put it in an interpretation. All right, guys, let's take a look at the next one. F prime of 1. So first of all, we need to find our derivative. What's the derivative of this function up here?
Negative 32 t plus 16.
Great. Now I want to plug in my 1. And what does that give me?
Negative 16.
Now, what is this telling me? What are the units, first of all?
Velocity.
This is velocity, right? Now, velocity is measured in what? It's something per something.
Per second.
This is feet per second. Okay? It's feet per second. So velocity is going to be in some distance over some time. So it's 16 feet per second. Now let's interpret that.
The time is 1, isn't it?
Yeah.
So would it just be 60 feet per second anyway?
At t equals 1, the velocity is negative 16 feet per second. At t equals 1, the velocity is negative 16 feet per second. Okay, so now we probably should write down a note because you guys had trouble with that. Velocity's units are some distance over time. Just so you guys know. We had that on the last one too with the average velocity. It's a little bit more obvious there because you see the distance numbers on the top and the time numbers on the bottom. But with instantaneous velocity, it doesn't come out like that. So you might just need to remember that. All right. I got one more example for you and then we're done. Here we go. So, estimating instantaneous rate with average rate. Now, we've done this before. Guys, let's say I want to find the slope of this curve at that point right there. Right? Don't you agree, like, sometimes you can't get the derivative. Sometimes it's impossible to find the derivative. Maybe I don't give you the function. But what you can do is you could pick 2 points that are really close to that and do a secant line instead. And the secant line, if it's close enough, should be about the same slope as the tangent line. The secant line is the average rate. The tangent line is the instantaneous rate. So my point here is that you can estimate an instantaneous rate with an average rate. These are very common AP FRQ type questions. So if A and B are sufficiently close to C, so C is the point I want, A and B need to be close to it. How close? There's not an answer to that, but the closer the better. If A and B are sufficiently close to C, then the instantaneous rate is approximately equal to the average rate. Okay? We've done average rate today. We've done instantaneous. Now we're going to do them together. This is a very common, like I said, AP type question. So here we go. Example 4. The table below gives the height of water in a fish tank as a function of time. Answer the questions that follow. So here's what this means. At t equals 2 minutes, the height is 10 inches high. So we've got a tank that looks like it's filling up to me with water. Okay? Now, I would think that the water's coming in at the same rate all the time, but who knows? Maybe like sometimes we're using 1 hose or 2 hoses and 3 hoses. Why the rate of the water coming into the tank would be changing, but maybe it is. Here we go. Use the given values to estimate the instantaneous rate of change at t equals 6 and indicate the units. So I want to find how fast the height is changing. How would I write that mathematically?
H
Prime 6. Good. So I want to find the instantaneous rate of change of h at 6. Now I can't. You can't do that with the table. There's no function up here for me to take the derivative of. But I can estimate that by doing the average rate of change of the 2 values that are closest to that. So, yes?
Would it be wrong if you put a d% instead of the approximation sign?
I don't know if they would ding you for that. I don't think they would. But let's do the split. Now, what? Yes, good job. So we want to pick the 2 time values that are closest to 6, and that would be these 2. So how much did the height change from t equals 7 to t equals 5? Well, let's see. The height. What is the height at 7? What is the height at 5? And how much time went by? 2 seconds. 7 minus 5 is 2. 18.5 minus 15.5 is 3. So that's 3 over 2, what per what?
For every 3 minutes,
Inches per minute. Now Jesse said something that I wanna highlight. Jesse said for every 2 minutes it increased. Notice that increased, right? Positive. It increased. He said for every 2 minutes it increased by 3 inches. This is an average rate. So on average, yes, you could say that. But since we're thinking of this as an instantaneous rate, this means that at t equals 6, the rate of change is approximately 3 inches per, 1.5 inches per minute is what that would be. Okay? So that's that. That's all of our things for today. So I would like you guys to go back and start working on your student practices with the remaining time.